Okay, so the thing to take away is we haven't done anything yet to make your system trustworthy. All we have done is record what you're running, right? And so the how do you make a system trustworthy really is going to come down to how do we use this information to verify what's going on. So this, as I said, is sort of the summary of how this setup works. So what could go wrong if you can call TPM startup and clear the PCRs at any time? Well, this would mean that you could start measuring whatever code is running at that point. The operating system could start measuring whatever it wanted to. It could load a different BIOS. It could have its own BIOS in memory that it never executes, that it measures. It could then have its own bootloader, its own master boot record. So the key thing is that we really care about which piece of software is in control each time we take a measurement. We want to know that the only software that is present is the software that we've already measured, so we know what it does, and that there's no chance that somebody we haven't measured yet and verify that we can't sort of decide later whether we trust or not has any impact on a measurement. So if we can reset this, then there's code that we don't have any measurements of because there's no measurements anymore that is now controlling future measurements, and we don't want that. So there's another thing that TPMs have is they have a counter in this, and counters are useful for a couple of reasons in security. So one thing we've seen are replay attacks, where you take old data and replay it. So a counter is nice because it prevents you from replaying things, because counters always increment if they're done securely. The other thing is that it allows you, having a hardware counter sort of gives you the ability to actually put a lifetime on things. So if you want to say you can only use this password to log in for 30 days, then the TPM can actually verify that time is incrementing. And the key thing is this is totally separated from the rest of your system clock. If you change your system clock to be 1999, the TPM counter doesn't care about that. It's just counting up, so it knows that real time has elapsed, which means it needs sort of some extra power source to keep counting even when the rest of your system is turned off. So one of the big applications for this is digital rights management, where if you want to, for example, download a movie from Amazon or iTunes, you have 2 days to watch it. How do they verify you only have 2 days to watch it? Well, they can put a secret, they can sort of store a key with the TPM and then use the counter to verify that you can't decrypt the video anymore when more than 2 days has elapsed. So this counter is sort of really built for digital rights management and for letting people borrow digital media for some period of time and sort of controlling how long they can use it. Questions or thoughts?